Imagine a region of space filled with static electric and magnetic forces. To understand how these forces interact within a specific bubble or volume, we look at a scenario where the boundary of this bubble is a special surface called an equipotential surface. This means that at every single point on this boundary, the pressure or potential of the electric field is exactly the same. The core of our story involves calculating the combined influence of the electric and magnetic fields within this volume. While this might seem like a complex task requiring us to examine every tiny point inside, a powerful principle called the Divergence Theorem allows us to shift our focus from the interior to just the surface. The vanishing act. The narrative takes an interesting turn when we apply the physical laws governing these fields. First, we recognize that the electric field is tied directly to the electric potential. Second, we know from the fundamental laws of magnetism that magnetic field lines never truly begin or end. They always form closed loops, meaning the net flow of magnetism through any closed surface is always zero. Because the electric potential is perfectly uniform across our bubble surface, we can essentially pull it out of our calculation. What remains is the total magnetic flow through that surface. Since that flow is always zero, the entire interaction we were trying to measure inside the bubble vanishes into nothingness. Extending the narrative, energy in the fields. This concept of shifting from volumes to surfaces isn't just a mathematical trick. It is how we understand where energy lives in the universe. Electric energy. Imagine a single point of charge. The energy density is highest right at the source and drops off incredibly rapidly as you move away. In a demonstration, you would see a bright glow near the center that fades to darkness almost instantly as the distance increases. Magnetic energy. Contrast this with a magnetic coil, like a solenoid. Here, the energy is neatly contained and uniform inside the cylinder, while being virtually non-existent outside. A visual demo would show the inside of the coil, filling up with a steady, even light. The infinite boundary. To calculate the total energy in the entire universe, we imagine our bubble growing larger and larger, expanding toward infinity. The reason we can calculate a finite total energy is due to a race between the growing surface area of our bubble and the weakening strength of the fields. Even though the surface of our expanding bubble is getting much larger, the electric and magnetic fields are decaying even faster. By the time our bubble reaches the edge of the universe, the fields have become so weak that any leakage of energy through the surface becomes zero, leaving us with a perfect measurement of the energy stored within the fields themselves.